In this video, we're going to describe now the last step of the strategic planning process. This will cover and touch upon machine learning control and reinforcement learning. Another way of looking at it is, this is actually the part of machine learning where the finance officer or the CFO who's interested in shareholder value will actually pay the most attention.
Let's remind ourselves where we are in the process. We've already set our objectives. They're financial, they're social, they are KPIs. In setting those objectives, of course, that'll have an impact on the deliverables. The second step is we're going to look through all the data we possibly can. We might apply some unsupervised machine learning tools. We call that, in my generation, data grubbing. Then we'll do some modeling, and modeling will yield maybe even more variables that we have to collect. Either we're going to predict some of those variables, or we're going to use those variables to explain other variables. Once we've done the modeling, we'll then go through a phase of option generation, looking at all the applications that are possible leveraging our data. Once we decide which applications are the most appropriate, doing a number of brainstorming workshops, we'll decide on the supervised machine learning algorithms to use. Perfect. Now, we then have to make a decision. Do we have enough information to present it to the C-suite, in particular the CFO, or do we need to add extra information? Do we need to tell the CFO, for example, how much money we're going to make or how much money we should spend in a particular area? If you have to make such recommendations, then you probably need to do step 5, which I call allocation. The algorithms that might prove useful come in the form of machine learning control or reinforcement learning methodologies. Let's start with machine learning control. If you ever venture into this area and look at the methodologies developed in the field of operations research or management science, you will literally be floored by the number of algorithms that have been created. In fact, what you need to understand is the algorithms that you'll likely choose are largely a function of the very specific project that you're working on. It is simply impossible to go through all of the different algorithms in this domain. Rather, what I want to focus on is, what are they used for? For example, imagine someone wants to know if they should increase their price or decrease their price. Should I invest more or less? Should I cut or increase my cost structure? These algorithms help us determine what the correct answer is, what is optimal. What we need to worry about is not being too afraid of the jargon, because it's more about what these algorithms do as opposed to what they're called that matters. So, what exactly do they do, and why are we talking about it as the last step? Let's refer to the profit function that we talked about earlier. Price minus marginal cost is my margin, times my units minus my fixed cost is my profit. This is an objective. That's our first step, step 1. Now, I want to maximize that number, but it's subject to a few constraints. For example, my sales may be a function of my fixed cost. Let's say that's advertising. You'll notice that this resembles very closely to supervised and unsupervised machine learning. A plus BX, my advertising budget for example, is something I would have collected during my data audit phase. I would have created a model that would say advertising predicts sales at step 4. That's supervised machine learning. In essence, in order to optimize a function, you typically have to estimate the constraints. The constraint estimation process is typically step 4, where we use supervised machine learning. In other words, if you want to run a business effectively to maximize shareholder value, you have to not only understand what data you have to know how to predict that data, and then and only then can you actually allocate resources in an optimal manner. So, what is the holy grail graph, visualization, that we're actually looking for? Suppose we want to know how many salespeople we should have. Well, we shouldn't have too few, and we shouldn't have too many. In essence, we have to map the headcount, or the advertising budget, or any fixed cost with profitability. Clearly, as we increase our expenditures, eventually we're going to hit a point where frankly it doesn't help anymore. At that point, we discover what the optimal profit is. Again, without being able to forecast the relationship between our fixed cost and our unit sales, it'll simply be impossible to estimate the optimal amount of money to spend to maximize profits. So, what kind of problems do these operations research models or machine learning control models actually solve? Here's a few examples. The first one is, suppose you want to minimize the fuel cost for delivery trucks. Well, you'd have to consider the roadways, bridges, traffic lights, and congestion. In a second example, you may want to maximize the returns on a stock portfolio. This will be subject to a couple of constraints. For example, the risk aversion level of the client and/or the volatility of stocks. Finally, you might want to allocate your sales force to maximize profits. Well, that'll be a function of the salaries of the sales force effectiveness, maybe the market size, and the contribution margins of what they're selling. So, you want to do an optimization or an allocation exercise. What's the first thing you do? You start always by defining the objective function. It could be for minimizing cost, maximizing profits, or any other objective you think is important. Then, you identify all the constraints that might affect the optimization of that function. That might require quite a few supervised machine learning models that would project sales, that would project costs, that might even project the effect of an external shock on my sales. Then, you go to the literature and you look at the specific algorithms that might serve your purpose. They'll typically have a name like dynamic programming, geometric programming, stochastic programming. Once you decide which of these programming algorithms you want to employ, then what do? You meet with your team and discuss how to get it done. People with the most experience with this type of modeling often have degrees in operations research or industrial engineering. In addition to operations research modeling approaches, you might want to consider some of the newer approaches called reinforcement learning. Compared to operations research modeling, reinforcement learning is rather new to the scene, but there are some new advances in that area. For example, you might want to check out the multi-armed bandit approach to optimizing online advertising and click campaigns. That being said, you might want to check out a couple of Excel spreadsheets that we've prepared. One is on response analysis. This area was pioneered by John Little at MIT, which allows you to allocate advertising spend, sales force, the number of retail outlets you have, even cell tower configuration in a mobile phone network. If you're interested in finance and stock market portfolio allocation, consider looking into the modern portfolio theory spreadsheet, which applies the Markowitz approach to asset allocation. Okay, you're ready to go. You've gone through the 5-step process. You now understand what your objective is, what kind of data you've got. You understand how to model that data. You're now estimating what those models are, and you're using them for optimal resource allocation. The only thing left is for you to present your findings and to have impact.